Suppose this is question number 9. We are asked to simplify x squared multiplied with x raised to the power of 3 divided by x raised to the power of 4. Now a raised to the power of m multiplied with a raised to the power of n is rewritten as a raised to the power of m positive n. So by this formula I will club these two components and rewrite this as x raised to the power of 2 positive 3 with the division sign followed by x raised to the power of 4. So this is going to be x raised to the power of 5 division sign x raised to the power of 4, which is rewritten as x raised to the power of 5 divided by x raised to the power of 4. Now if you were to move this to the numerator, this is going to be x raised to the power of 5 multiplied with x raised to the power of 4 with a negative sign. According to the law of indices, this can be rewritten as x raised to the power of 5 adding negative 4 will give us x raised to the power of positive 1, which is equal to x. So therefore the solution is x for this question. Now this can be rewritten as follows: a raised to the power of 3 over 2 times b raised to the power of 5 over 2. Now the square root, right? I can represent this as ab raised to the power of 3, or I would say ab raised to the power of 3. This entire thing is raised to the power of 1 over 2. So this could be rewritten using the law of indices. Suppose you got a raised to the power of m, which is in turn raised to the power of 1 over p. I can rewrite this as a raised to the power of m over p. So using this law, this can be rewritten as a. Now this 1 over 2 is also hitting a, right? So this is going to be 1 over 2 there, and then b raised to the power of 3 over 2. And this is a raised to the power of 3 over 2 and b raised to the power of 5 over 2. Now you can club the a's together, a raised to the power of 3 over 2 and a raised to the power of 1 over 2. Club the b's together, b raised to the power of 5 over 2 and b raised to the power of 3 over 2. And you can add these two. When I say add, using the law of indices, so this is going to be a raised to the power of 3 over 2 plus 1 over 2, b raised to the power of 5 over 2 plus 3 over 2. This is going to be a raised to the power of 2 common LCM. So 3 positive 1, and this is going to be 2 is the common LCM, 5 positive 3. This is rewritten as a raised to the power of 4 over 2, b raised to the power of 8 over 2. 2 divides here 2 times, 2 divides here 4 times. So you have a squared times b raised to the power of 4. So that's the solution for this question. Now we have f of x is equal to 2x negative 3. We are asked to find f of 2. So we substitute, put x is equal to 2. So that's going to be f of 2 is equal to 2 times of 2 negative 3, which is 4 negative 3, which is equal to positive 1. So therefore f of 2 is equal to 1. So you can box that. Next, f inverse of 0. So for that we need to find f inverse of x. So I'm going to take f of x is equal to 2x negative 3, and this means you have y is equal to 2x negative 3. Okay, so replace x with y and y with x. So this is going to be x is equal to 2 times of y negative 3. Then you rewrite the entire equation for y. So that would mean you have x positive 3 is equal to 2y, which means y is equal to x positive 3 over 2. So therefore f inverse of x is equal to x positive 3 over 2. So that's the solution. Now we are asked to find when x is equal to 0, right? That's exactly what they want. So f inverse of 0 is equal to 0 positive 3 over 2, which is equal to 3 over 2. So therefore f inverse of 0 is equal to 3 over 2. So you substitute and you get the value. Next, f inverse of 2. That's the next question. So you put x is equal to 2 in, say I'm going to take this as say some 3. In 3 we get, so what do we get? F inverse of 2 is equal to 2 positive 3 over 2, which is 5 over 2. So therefore F inverse of 2 is equal to 5 over 2. You can box the result. So that's the solution for the question. We move on.